Hi ladies and gentlemen, this is Mr. Green and this is another in the series of videos that I'm making for Algebra 2. Today, I've got something special for you in a minute. What we should be doing is you should be completely through with Unit 3. You did get the first part of Unit 4, which dealt with uh, inequalities. And I don't forget to you can make corrections. You're going to have to send them to me via Kmail, but I do take corrections and talk about those type of things. But today we're going to talk about compound inequalities. Wait a second, I know what compound means. That means putting two things together. And you know what? I've got something for that. For that, I am going to play a guest song. Yes, a little bit of this.
Conjunction, junction, what's your function?
Hooking up words and phrases and clauses.
Conjunction, junction, how's that function?
I got three favorite cars that get most of my job done.
Conjunction, junction, what's their function?
I got and, but, and or. They'll get you pretty far. And, that's an additive, like this and that. But, that's sort of the opposite. Not this, but that. And then there's or, O-R. When you have a choice like this or that. And, but, and or.
Well, enough of that little bit there. But that's just to give you a clue of what we're going to be talking about, okay? We're talking about conjunctions and disjunctions. We're trying to put things together. We're going to try to solve some compound inequalities that give solution sets graphically and using what we call an interval notation, okay? That's what you're going to see right here. So let's get into this a little bit, okay? So the first thing is a conjunction is a compound statement that uses the word and. A disjunction is a compound statement that uses the word or. A compound inequality is a pair of inequalities joined by the word and or the word or. The compound inequality is a type of compound statement. So here's an example of a conjunction. Here's an example of a disjunction. Now, conjunction, you're going to get one line or line segment or ray or whatever you want to call it, but it'll just be one of them. In a disjunction, in a disjunction, you're going to get two, not just one, but two. Conjunction one, disjunction two. Okay? So let's look at some examples. If I were to write x greater than 2, well, I got to get my pen going here, and what we're going to say, x greater than 2. Well, I'm going to put a circle around 2, and I know that it's everything that direction, right? And then I've got x less than or equal to 7. Well, that's a solid point around 7 and everything that way. You notice where they overlap? It makes one line. The way you would do this in an interval notation, you would say x is an element of, okay, x is an element of, and you would say 2 on the low end, and you would say 7 on the high end. But the 2 would be an open bracket, and the 7 would be a square bracket. Sorry, I have to cough every once in a while. The open bracket indicates that it's an open-ended statement. See how you got the open circle here? So if you got an open circle, you would have an open bracket on the 2. Since the 7 is a solid end circle, it's going to be the solid bracket there. Okay? So let's look at this one. X greater than 5. Well, let's start right here at 0, 1, 2, 3, 4, 5, and just for grin, 6, 7, and 8. Out like that. Okay? X greater than 5. Open bracket at 5 and going this direction. X greater than 7. Open bracket at 7 and going this direction. Wait a second. Mr. Green, you said it'd be one line. Well, this is not in both of the statements, is it? And since we're saying and, it has to be in both of them. The only thing that's in both of them is x being an element of the open bracket 7 and infinity on the high end, open bracket. That would be my line segment that I'd be looking, for. Actually, it's array, but it still would be, that's what I'm looking for. Okay? Maybe a little drink will help there. Okay. So this last one here says x greater than 0, open circle around 0, and x less than -2. Well, x greater than 0 is everything this way, and x less than -2, that's an open circle there, and everything going that way. Wait a second, I got two lines there, and they don't overlap at all. So x is not an element of anything. Okay? So x, an element of absolutely nothing. Null set. Okay? So let's go forward and look at this next one. Here we've got examples of conjunctions, and I want you to notice if they're both less than signs, it's going to be everything in between. And if they're less thans, it's open circles in both cases. And you got open brackets, and the x is an element of in here. If they're less than or equal to signs, they're solid in circles, and your brackets here in your interval notation are squared in brackets. Okay? See? Solid circles, squared in brackets. Here you've got one less than and one greater than, open circle, solid circle, open side, solid side. Here you've got less than or equal to and then less than, solid circle, solid bracket, open bracket. Okay? So just have to keep track of which one is which one there. Always put the lowest number first and the greater number second. This little symbol in here means is an element of. Okay? So covered all those bases. I think everyone understands that. So let's look at a disjunction for a little bit here. X less than or equal to -1. Well, that's a solid circle here going this direction. Or x greater than 3. So that'd be an open circle at 3 going this direction. I think I've got two different values there, right? So t greater than 4, open circle at 4 going that way. T greater than 9. Well, 9's out here, open circle there. Oh, wow, going that way. So I think my interval here is going to be x as an element of 4, comma, infinity, open circle bracket. Why am I saying that? Well, 4 is not a part of either one of them. That's why it's the open bracket on 4. But 9 out here is a part of this one, so it's going to be that it's going to include it in this interval out here. Okay? So z greater than -2, that's going to be an open circle at -2 going this way. And z less than 1 be an open circle here going that way. You know what? That's going to include all real numbers, isn't it? So x is an element of -infinity to +infinity. Open brackets on both sides. You notice I'm putting open brackets on the infinities. Infinities aren't really numbers, so you just have to keep going with them forever and ever. Okay? So let's write this. See how it's just one line? I know I'm going to have an and here. And I'm going to have x is greater than -3 and x is less than or equal to 3. Down here, I know it's going to be an or, isn't it? I've got x is less than 1 and or, that's an or x is greater than 5. How do I know they're greater than or less than? See the little black inside the circles? That means they're open circles. Right? So, when I get compound inequalities like these, what you have to do is, first of all, solve them for just x or y. In this particular case, I'm going to subtract 5 from both sides of the equation. I'm going to get x is less than 2. But there's an or here. What I have to do is solve the other side also. So that means I'm going to divide by the -2, and I'm going to get x is greater than or equal to 5. Wait a second, Mr. Green. Why did you switch that sign? Because we're dividing by a negative number. Remember our inequality rules. We divide by a negative number. That sign there, that, that less than sign became a greater than or equal to sign. So graphing this one, I would have at 2, an open circle, and at 5, 2 and at 5, I would have a solid circle at 5, and everything greater than 5, and everything less than 2. So over here, once again, two equations, gotta solve them both. So I'm going to add 1 to both sides of this equation and get 3x greater than 15. Divide by 3, and I'm going to get x is greater than or equal to 5. And then over here, when I divide by 6, I'm going to get x is less than or equal to 8. So here's 5, here's 8. So I've got 5 greater than or equal to 5, so it'd be solid at 5, less than or equal to 8, be solid at 8, and it's everything that's in between the two of them, like that. One line, one little line segment. Okay? Well, this one doesn't have an and or an or in it, Mr. Green. How do you solve that? You do the same thing. You treat all your things like it was, like it did have them. I'm just going to draw little lines here, okay? Because I don't have to do these things once. I got to do them twice. I'm going to subtract 10 from both sides of both sides there. 12, 10. Okay? So 4 minus 10 is a negative 6, less than or equal to 2n, less than or equal to 8. Now I'm going to divide by 2 all the way across, and I'm going to get negative 3 less than or equal to n, less than or equal to 4. Okay? So where am I at? Here's negative 3, here's 4. So I've got x is, or n must be negative 3 is less than or equal to n. That means it's a solid n circle going this way, and it's less than 4, less than or equal to 4, solid circle going this way. It's everything in between there, isn't it? This must be an and statement. Look at this one over here. Once again, two statements, going to solve them independently. Subtract 1 from both sides. I'm going to get 3x greater than or equal to 7. And x is greater than or equal to 7 over 3. Over here, I'm going to divide by 10. And I'm going to get x is less than or equal to 1.5. Well, 7 over 3 is actually equal to 2 and 1/3. So what am I looking at? There is 1, there's 2, there's 3. Well, 2 and 1/3 is right there, and x is greater than or equal to 2 and 1/3, so solid circle there, going that way, and I would say 2 and 1/3. And x is less than or equal to 1.5. Well, there's 1.5, 1.5, and it is less than or equal to that, so solid circle there, going that way. There are my two drawings. Okay? Moving forward is in the next week. So, what I want you to do is when you're sending me communications, make certain you include that you're in Algebra 2 so that I can find your records quickly. It helps me a lot. It really does. I appreciate it, and I'll see you all next time.